Very nice.
I just want to go to that page. So this is all hands-on.
Yeah.
You can.
Laptops
you are
out.
Encouraged. At least encouraged to follow hands-on everything that will be showing.
Enforced. If you don't follow along, you'll have to
Okay,
leave. Yeah. Who's played with this stuff before? The online editor? Yes? Like 3, 4. Offline editor? Has anybody played around with the VS Code stuff yet? No? You have?
I don't know, the old one, the old one is Sublime.
Oh, syntax highlighting in Sublime.
So you're about
So much more. We're going to blow your mind.
I think I installed it in VS Code, but I never used it.
What's that?
I think I installed it in VS Code, but I never had time to use it.
All right. Okay.
Let me see,
Yeah.
just launch it and I'll see if I installed it.
So that's the session IDs. 16 of them.
Nice.
That's the low-tech approach.
Yeah, yeah.
Ah, so you are Jan then.
I'm Jan.
Yeah, so your name is in the thing I downloaded, so I haven't installed it.
Yes.
You sure it's not the other Jan?
If it doesn't work, blame him.
Evil twin brother Jan?
Well,
He's Jan with 2 N's, not 1 N.
well, here it says, well, it's the same Jan.
What?
You're pulling my leg.
You expect any less?
All right. We'll give it a few more minutes to trickle in.
Yeah. We'll get the stuff here if you want.
What? Cool.
Should we ask for volunteers to be used later?
At the point when it comes, yes.
You don't want to do it now in advance?
Oh, we can. Sure.
Okay.
So again, newcomers, that's the page with all the resources and links you're going to need. Computers on. This is one of the sessions where nobody gets punished for using a computer. Apparently you get punished if,
That's right,
you, don't,
if you don't.
if
Yeah.
don't follow what we do.
You could try it on your phone and see what would happen.
Yeah. What if I don't have computer with me?
We do not supply computers to it. No. You could look at Ron's computer and then, the two of you. So we also need 16 volunteers. Not just one volunteer, but 16. So people that are going to follow along, take the code, try stuff, and your name won't be put, their name isn't extracted.
No, it's
right?
anonymous.
No, it's all anonymous. So if you are following along and you're doing this sort of thing, it would be extremely useful just to show and demonstrate what's going on. Ron?
I guess.
Attaboy.
You have been volunteered.
15? Anybody? Yeah? Let's go through. It's not a big ask. It's just play around, add some random text.
No, you're actually
Oh, you don't
going
have
to
a
be
computer.
solving a PDDL problem. Not solving a PDDL problem. You're going to be modeling
You will be scored.
the simplest PDDL problem ever, though.
Anybody else? Would you like one? Will you be following along? Yes? No?
Yes.
Yes?
Yes.
Yes?
He said yes.
That's it.
If I manage to. I'm going to play in general.
I would just like to.
Are you going to follow along? Yeah? Sweet.
That's right.
So I don't have admin privileges. I can't install anything. Is that going to be an issue? That is an issue.
I mean, it's going to be
There's no like web version or something like that that I can.
student 7 session load. I mean, you could put this in. You could do it. Of course, there's a web version. Come on.
Unless there's a
What do you expect? It's a far richer experience if you could do both the online and the offline version. So we hope that you start going to this link, installing VS Code and the plugin and that sort of thing to really see the full power of what we're about to show you. The what?
So you're going to
We'll
need
explain it at some point. It's
Visual
just the
Studio
rules,
Code.
but-
If you
Alvaro?
search for the download page for Visual Studio Code, meanwhile, or find it
Come
on
on,
this page,
come
of
on.
course.
Are you going to follow along, Rick?
That's the only thing that may take
Are
a
you
little bit of
following
time.
along? With your laptop? You got battery?
I have some battery left.
You're on microphone right now, so careful what you say. Everything is recorded.
If I make visual contact, I have to. That's what I tell my students. If you make visual contact with me, you have to answer questions. Yeah.
If I find 5 more people, accept the challenge. Accepting the challenge. You don't know what you're signing up to, but yes, here it is.
I've already been drafted.
Last one. One last.
Going once, going twice.
There it is.
Oh boy.
So everybody else could use that ID up there and follow anonymously completely. When it comes to that.
Is
We'll
that,
come to that in about 15 minutes.
Is that a read-only link?
That's the real
Maybe we
link.
should give them a read write and just let them like step on
Oh,
each other's toes. It'd be awesome. It'd be awesome.
All right.
Should we get going? I think we have enough trickle in. Yeah. So, welcome, Florian. Welcome, everybody. This is going to be a non-standard tutorial. We run them very rarely at ICAPS, but I think they are kind of the best that you might get. Hands-on tutorial. We do hope you have a laptop with enough battery left at the end of the day to actually follow along with this and play out with what we're going to show you. So Jan here has produced, over the last number of years, a very rich offline, fully featured IDE experience for authoring PDDL. Myself and Christian, I've, over the last number of years, authored an online experience, perhaps not as big a depth in industry-based PDDL authoring, but a far richer variety of what you might want to explore in terms of prototyping visualizations for your PDDL and so on. And so what we're going to present to you is sort of the whole scope of these two different experiences and how they tie together as of just a couple of weeks ago, and sort of the closed loop that you might do in a classroom setting or in a deployable setting if you're in industry, and everything in between. So if there's any questions as we go, please raise your hand and bring them up. This is meant to be interactive. We do hope, again, that you haul your laptops out and follow along, at least with the online part, and hopefully for the offline as well. It does require installing VS Code, but very little beyond that. Right? So initial instructions, go to that URL, get started with what's there. I think what you'll see is what you see here. Right? So the prerequisites, install Visual Studio Code, install the PDDL extension. Everything else should be good to go from that point on. Am I missing anything from the outline? No? So for the first part, before I hand it off to Jan, I'm just going to demonstrate a little bit of what we have in the online space if you want to be dealing with PDDL. So planning.domains was introduced a few years ago. There's 4 pillars currently for this: an API to get access to all of the different classical domains at current and other types of domains in the future, an online solver service if you want to throw your PDDL via JSON and get answers back very quickly, then you could use this service for you, an online editor, which is where we'll spend most of our time, and then a collection of education resources, which will include this tutorial eventually when it goes up online, and different course materials, source for the coursework. If you are instructors, reach out. That's what the education portal is for. So the online editor itself, as of a few years ago, it was extended to allow for a plugin architecture so that anybody who wants to extend the features and functionality of this online PDDL editor can using the framework that's there and have their plugins featured inside of the list that goes on here. So new to ICAPS this year is a number of plugins that have just dropped and are worth highlighting. And what I thought I would do for just the first few minutes is to sort of explore around this online editor, show what it's capable of and show what's there. And then we'll transition to how this can be taken to the offline setting and expand on the capabilities of what you might do in the PDDL authoring experience. Right? So the online editor is things that you might expect. Let's start with the help screen. So you can save files locally. You can open files that might be on your computer. You've got tab functionality on the side. I'll get to sessions later. And there's just a number of small things that come out of the box with the online editor. What you would expect for anything that's in a domain-specific language is auto-completion for the types of things you would need to write. Right? If you care about derivative actions, then you have auto-completion for snippets of derivative actions. If you care to work at night, then you've got nice color coding for PDDL and not for Lisp like most people do when they write PDDL in Vim and just change your language settings so that it looks a bit better for that. But expanding things a little more, we have the functionality to import from all of the pre-existing IPCs and the pre-existing collections. And this comes from the API at planning.domains, right? So you can import files that you might want, see statistics on them, run a solver that's sitting in the cloud, again, using the service that I showed before. Nir, what's going on with your solver? Aha, unnamed, domain, problem, go. Right, so it returns the solution. You're able to see things in a very linear form. This is the kind of stuff you would expect right out of the box with, being able to very quickly do PDDL, solve, and so on. The appeal for this is that you can all go to it right now without installing anything. And if you want to show somebody who's asking you, what the hell is PDDL? Why do we want this in our company? You can say very quickly, look, this is a small declarative specification. Look at this solution that's 50,000 actions long, and it took our solver half a second to solve. It doesn't scale like that, but you get what I mean, right? You don't have to figure out the dependencies and install the planner and all of that just to get going very, very quickly. So what else do I want to show from this? When the plugins dropped, the first thing that we attempted to do here was a set of miscellaneous plugins. So miscellaneous PDDL generators. Now, if you've ever modeled PDDL before, you'll recall that sometimes you have to be pulling teeth in copy-paste errors just to get certain key functionality down in your model. So what this plugin gives you is the ability to insert things that are very common to many models. So for example, numbers is a very frequent thing. If you are in a setting where your numbers are not allowed, but you want to have numbers in your domain, you could say, I want my maximum numbers to go to 12. I care to call the fluence num underscore number. Successors is good. I don't care about predecessor, and let's talk about sum. Right? So it now says insert these objects inside of your problem file somewhere, and it automatically generates all of the successors for you that you would be doing by yourself, all of the sums, and this sort of thing. Right? So this really sort of shows the type of thing that plugins can be very useful for, sort of like a Swiss Army knife of inserting these PDDL. The next thing that I want to show is something that I really didn't have to do much for at all. And I'm going to go over here to one where I have some of these problems already lined up. Torchlight, if you're unfamiliar with it, is something Nork Hoffman introduced, a really nice analysis tool of domains. And so Torchlight, you very simply host it in the cloud, throw stuff at it like you would throw PDDL to a solver to ask for. And what it does is it analyzes the domain for you in terms of dead ends and reachability and all of this sort of stuff. And so it gives you a full reports down here, and there's a README that describes all of this stuff. So again, this is yet another utility that you might have. So if you're thinking, oh, well, I did something cool that just takes PDDL and does something cool with it, wrap it up in a plugin. It's very small footprint to do this, and you can expose it to the community in this sort of way. So moving on from Torchlight, this is all stuff that's existed in recent years, but new this year is a trio of new plugins. Mao has produced 2 of them, and Nir and team has produced another. So I just wanted to highlight some of this cool stuff to you guys. So the first up is Dovetail and Statespace. And again, this follows the common pattern where you send it PDDL, so you select the domain in the problem file, and then you're asking for some, ooh, that was the wrong thing to click. Are these on different servers? No, do you know? No? Okay, so we might need to wait for a second for that to fail. Right, I selected the wrong problem. You should send only the right stuff to the right domains. But the dovetail and the state space plugins are new ways to visualize what a plan might look like. The state space is a state space visualization, as you would expect, and you can sort of unfold and collapse and pick through the things that are there. And the dovetail sort of shows a different way of demonstrating what the action preconditions and effects actually are. Any chance you're able to reset from your laptop? Yeah, so I think I just tore it down by sending it a massive payload. So maybe we'll get that back again to show. In the meantime, Planimation is something that will be introduced at the demo session. Actually, all three of these plugins will be introduced at the demo session. Planimation is one that accepts a domain file, a problem file, and an animation file, which allows you to annotate the objects and the actions that you have in your space. And so running Planimation on, let's try and do it the appropriate way this time. Here. With the right animation file, and Nir will be able to describe all of this for you, it gives you a dynamic animation of the solution that's produced as part of this, right? And so this is a logistics problem where you're moving around blocks and boxes, driving in airports and so on. So this is something that should be familiar to most in the room, but it allows you, again, to sort of wrap up this nice functionality that exists elsewhere on the web as a plugin to this online editor. And it allows you to sort of do it all in a single source. Let me try one more time to show this, because it's really cool stuff. And I messed it up by sending the wrong payload. No. Okay, so if we have another chance when we turn back around, what I want to pivot to now is to show how this online experience, say creating a number of PDDL files that you're trying to diagnose, figure out, and create for yourself, can be shared among different people and brought to the offline setting. And so if I go back here, say to this problem, for some reason the PDDL isn't working, I need help, my actions are all messed up. Something that you can do now is to session save, and it gives you two links, a read link and a read write link. The read-only link is something you can share with people. It will load up the exact same tabs, the plugins the exact same way that they appear and how you've configured things, and it allows them to make edits, create their own session, and send it back. The read-write, you can use this as a way to save your own work. You could go back to it, continue, and that session will continue there. In fact, what we're sharing with you are read-only links, and we have the private read-write link that we can change if we find any bugs with what it is that we're doing. Now, the addition to this is that the read-only and the read-writes can now be open offline. So in a session, as you're working at this point, and you say you want to open offline, what it's going to do is give you the option to open this in Visual Studio Code, right? And if you already have this installed, it should open up things for you. If you don't have it installed, it will ask.
Which is the case that I've created here, like if I never had that.
This is the very first instance. So if you've installed VS Code but you don't have any other plugin, then this is the sort of experience that you would get when you're opening this. And so we are trying to demo everything live from scratch as if you were coming into this, just to make sure that if we hit roadblocks, it's the same roadblocks that you're hitting. Now, we've passed out 16 individual session codes, and this will be used later on to showcase how this might be used in sort of a classroom setting where you have a number of students that are working towards a common modeling goal, and you want to have a good overview assessment of how things are going and how the students are progressing. So as we step offline, I'm going to sit down and hand it over to Jan. And we'll
Thank you. Maybe I was too ambitious for the... No. Just
We're
finished.
mostly okay.
Okay, perfect. So here we are. We asked for that session that we saw online to be downloaded offline. It asked whether we want to install the right extension, and it did install the extension. And it showed us this overview page on which you will always find all the necessary configuration, the most important configuration that you will need to run. It will ask you, it didn't ask me, interesting. It will ask you to install the validator. Have you got your hands on the val set of tools, the validate, the parser, and a number of other things in there from KCL's GitHub? Okay, so that's what you can download quite automatically by pressing one of these buttons, but it should be reminding you. it's reminding me, so what's going on? Do I have my files open? No. I should have clicked that button that was telling me reload this to see what you wanted to see, right? Okay, so accept it or reload. You guys are getting going. Is it installing? Is it fine?
Or it says it's not available on the Darwin platform.
Uh-huh.
Is there any easy way around that?
Not right now. We spent actually 2 days of an intern time last week trying to figure out how to get the right tool chain for CMake compilation on Darwin. If anybody has that knowledge, I'll be very available to find out. So, okay, here we are. So that's where it's actually telling me you need to pick where you want to store this. So I'm going to go somewhere to some PDDL and say, this is a folder for the demo. Just download the session right here. And if you've ever cloned a Git repository, the experience will be very similar, right? So here are the files. These are, you recognize the files. That's what you created, right? And right away, you should be able to see that, yes, so that's the files that we saw online. We can right-click on any of those files and say, run the planner. Now that will run the very same planner and bring back the plan, even visualize the plan with some colors, right? So that is not very exciting for a plan of this shape, but we're going to come later to some more interesting plans. Meanwhile, also, what I didn't accept was the hint. If you want to see what it can do, invoke the tool palette, which is done by F1 on most operating systems, I think, and type PDDL, and that's going to pre-select from a long list of commands, the long list of commands that the PDDL extension itself can do for you. The overview page that we were looking at earlier was also suggesting that I can get some better icons, so you see how these files are indistinguishable from each other and from PDF files and whatever else you will have in your projects. If you accept these things, it will start showing things that are far more readable, but let's also change the color scheme here to something lighter. I think that's going to be more visible, right? Is it better? All right. Okay, so what we need to know about this environment is, well, there is the navigation here. We are going to use the source control, we are going to use the file explorer, which is the first one, and we are going to use this test explorer, right? At the bottom, you will see, just as if this was a Git repository, this is telling me that 4 minutes ago, this session was actually created and last updated. So we basically hooked up the planning the domains server to this environment via the source control capability, so that if you've used Git or things like that, you will be familiar with it. Compilation errors, so now you see parsing errors. So basically all there is here, what we're going to go through is features that I realized I needed to build to be able to teach effectively my colleagues at Schlumberger PDDL and planning, and make it possible to integrate planning into their solutions. So PDDL now has the first-class citizen support. You will see the same features you would be familiar with from other languages. You can hover over something and get okay, we'll be hovering something else later. But basically PDDL, whether it deserves it or not, it now has the first-class citizenship you would expect from modern languages and modern IDEs. Let's switch though to something that we're gonna need for the challenge that you have your tickets for the lottery. So let me create a new one. Let me start a new editor session, and just for the sake of it, if you type domain, you will get the skeleton domain here. I'll just save that and I will open it in the offline editor. Here we are again, sorry about that. Everybody awake? Now you got several options here because we already had a session open. Now I can open it in a brand new workspace or edit side by side with this session. You can have multiple sessions and basically working on multiple things in parallel. Or I can wipe out whatever was here, actually wipe out whatever was in here and overwrite it with that one file, right? So now we have that session and I can start doing things to it. So because this is an IDE, I can of course add some files to it like readme file and tell the students this is your assignment, right, for the week, right, and give them some instructions and there is a file. But what we are going to do as the first thing typically people do in any programming language, they try the hello world. They want to write the hello world program. And yes, so there is a hello world that can produce a plan that says hello. Actually, that was far more readable in here. Right, it says hello. So now we have a couple of hello world files in here. And if you if you basically remove some things from here and save it again, you go to the version control and see these are the two files, and I'm getting an annoying error here. I can save it back to the server, like if it was Git server, and there it is. Now I can see it online and collaborate, spread it further, and so on. Now what you got as a challenge is the code for the session that was created for you, or you use this one from the wiki page. You can put it in either, I guess the way you would normally do it is you go to session and say load and paste that code right here. You cannot paste it if you got it on a strip of paper, but type it in there, load that session. Anybody done that? Is it working? Did you get to your session? Okay, perfect. So your challenge is to basically finish the assignment, right? It's the Hello World PDDL 101. And I'm going to play, you are playing the role of all the students. You'll be teaching students, but now you take the role of being a student. And what I'm going to do is I'm going to be the teacher. So I can open my workspace that was already prepared by cloning that Hello World session 16 times. And I have my original template right here. And essentially what I did was in the version control panel, I went to that session, and in those choices I had here, I could do a few things. Right? I could duplicate that as writable, which is the same thing you could do in the online editor with a save button, or you could generate an entire classroom. Right? So what I did was I clicked on that, and basically, well, following that example there, you would just put the names of your students, and it would clone that one session for all of your students. And all you need to do is basically tell them, open this was prepared for you, and you start working on that, right? So now I can see what's your progress. And so far, nobody has saved this. These sessions were created 2 days ago. So someone save your work. Right, so what you do,
saving locally from VS Code.
Yeah, so, well, VS Code, if you toggle on the auto saving, you will be saving to your hard drive. But you basically need to come here, and for the files that you changed, send it back to the cloud. Working for anyone? How is your Hello World PDDL coming up?
If you're in an online session VS Code val installed at the moment, session save should do exactly the trick for you. So it'll override the session that's there. You've opened a read-write session, and that's what it will do.
Okay, while you're working on it. So the other things that I took advantage of here was that I've created this kind of small file, a JSON file with a name ending with .ptest.json, basically shorter for PDDL test. And I said, well, the domain file is the hello world domain, and the problem file is the hello world problem. Right? Run it as a test case, and what you are asserting is that the plan matches a plan in the file that you have there as well. Right? So the plan is expected to look like that. It's supposed to have say hello world action in it and nothing else. And now with basically this file, you will get your test cases defined. So that's the same, that's the view of that file. You can imagine how you could have many more test cases in here, give the students assignments with growing level of difficulty, right? More challenging things to put into the domain file, and until all of that passes, they can't go home, right? So meanwhile, student 1, student 2, they all have the same things because I've cookie cut that, right? So I can run that as a suite of tests. So if you are a software developer, architect, or anything, you would use this kind of an approach as a continuous integration, right, of your domain file. You will be maintaining domain files over time, making sure that it still solves the problems that it solved yesterday after you've done the modification today. That's what you would do, right? You would be running this in a continuous integration fashion. Now, one guy solved it. Oh no, that's my finished. All right, who's the winner? So next year we are going to have the ICAPS contest for ICAPS contest for modeling something.
We'll give everybody the hello world problem.
Yeah, the hello world will be the simplest there in the challenge. Do you know what to do? Anybody doing the hello world assignment?
Yeah.
Are you done?
Yeah. We're saying overload the test pane, but I don't see the test pane anywhere on the here.
So you don't have test icon over here with a beaker?
Oh, yeah, so I couldn't get the VS Code to run. Is there a way to do it through the online?
No. So
No.
this is the key point of it. The online version you can view as a stripped down. It doesn't do continuous integration and development. It doesn't do all of this extra stuff that a full-fledged IDE would do, right? That's what VS Code is.
Right.
And we just collectively as a community don't have the cycles to re-implement a full-fledged IDE.
You guys were asking for someone to submit, so I was trying to.
Yeah, so you should be able to submit
Okay.
in the online version by just saving the session that you have,
And I
right?
did do that.
And if you look at the overview pane, when you say session overview, do you have the same code that was given to you as your read-write link?
I do not have an overview.
So the overview pane you get by pressing F1, typing PDDL, and then selecting show overview page.
Are we sure these are read-write links and not read links?
Read write. They're long. Trouble saving it?
Trouble sending it back to the server. Which
No, here it says it went in. But, I saved it.
Yeah, so there are no
EMNO.
changes
No change.
visible there. So looks like, yep.
EMNO.
Refresh any of them. Student 3.
Oh, yeah, student 3 up there.
Oh yeah, yes, there we go. Perfect.
Ah,
Yeah. Excellent. So let's look at that.
If you're an instructor, be sure to look at the stale tag.
Yeah, exactly.
Yeah.
So that stale thing says the session is out of date, right? And the icon is suggesting you may want to download it, right? So the student 3 already updated. I can download the latest one that was saved a minute ago. Okay, so you guys were actually busy. I was just not refreshing fast enough.
They're all timestamped, so we can give awards to whoever's finished it first.
Yes, we still know.
Does ICAPS have funding for that? Awards announced on the spot. Can we get funding for that?
Maybe lots of tries. I don't know. Photo finish.
Oh, yeah.
Okay, so there we go. There are plenty of changes. Let's go back to the contest. Run it again.
There's a student 2 check.
So yes, student 2, congratulations. Student 3, congratulations. 4, actual plan.
Interesting.
Good, so you managed to
Very
produce a plan,
interesting,
but perhaps the action name is different.
Yep.
Right. And one other like that.
And so could we view the plan from this point?
So we can click on the little eye there, and let's take more space. So what changed here? Yes, so it's basically the name of the action is different than expected. I can run the planner by Alt-P on Windows is the registered shortcut for that. And yes, we have a plan, perfect. It's slightly different. You can view the plan by exporting it again as a file. So that's the actual plan. And now you can see that, where was it? What was that student? Student F. So student F has got an expected and a actual plan. If I select both of them like that and right click, as any IDE, it would let me compare those, but we have a PDDL-ish compare. So we can normalize times, sort actions by name alphabetically when they start on the same time, do things like that, and run the diff. There we go. So then the diff is, there is basically just underscore versus hyphen. So we can change that. We can change that by modifying it over here. But if we wanted to change more things, and let's get this up again, because this is a developer environment, right? If you wanted to change this thing, this is a predicate, I can press F2 and modify that to, for example, put a hyphen here as well, or whatever I wanted here. Very audible here. Right, and now you note it changed it everywhere it could find it in the domain file, or if you had multiple problem files, it would change those too. All right, so that's how it should be solved. Congratulations to 4 winners. You'll get a diploma or some sort of reward. Tasty. Right, what else you get here, because this is a developer environment, you get, you probably ran into it since you used it hands-on, but you can hover over things and see their explanation with the documentation, right? This is a thing. And you can control click on it and jump to the declaration of it, which is right here. And this is really where the documentation string came from. And it even takes markdown syntax, right? So you can be very expressive. So basically, I will not go to all the details, but that's what you get as you expect. Well, different from other languages, what triggers the auto-completion here is typically parentheses. When you open the bracket, that's where you start typing some PDDL, and you have the syntax suggestions for all kinds of things. Here is my predicate, right? I don't have to remember how it's called. I can just start typing said hello, and there it is. It basically inserts the right predicate. The red squiggly line, that comes from the parser. So if you installed the val binaries as suggested when you start it, you will get these warnings and syntax errors, and that's coming straight from the parser. Et voila. So that's the basics. Anybody has a question there before we go deeper? Everything clear? So syntax reporting, PDDL source control. So we were adding files, adding instructions, duplicating the session. Yeah, jumped over it. Okay. We had a classroom set up and we were monitoring the progress by looking through what is stale over here. And then we were comparing how everyone has done by looking at the pass-fail status. All right? Mm-hmm. So now let's go to something more challenging, right? So Hello World is not going to impress anyone in any industry, really. Even Blocks World is, really? Mm-hmm. Right, so I have few more, hopefully more interesting examples. You will find them in a Git repository that I maintain as well, side by side with the extension. I have also used, and that's useful for giving demos, right? This facility to have test cases predefined. I use it for demos as well. So this is my ICAPS 2019 file. You know, that's still the same kind of JSON file as you saw before. And it just defines one demo after the other. So I could just go through them easily and not forget something. So here is a more interesting domain which solves some kind of a logistics problem. But what's interesting is if I run that, it produces multiple plans. It did not. Hang on. It produces one plan. And if I run it from here, it has a switch to produce multiple plans. All right. So here are first 4 plans it came up with, and you could compare them, render them all. You can see what they stand for. The size of the green bar is the metric value of the plan, and basically it's going from some place from Houston to El Paso, and it has a choice of using a regular slow road or a motorway, which is how you get there faster. And down here, because you installed Val, so Val now has few more tools that Derek Long worked on over the last couple of years. It, for example, takes your plan and looks at, basically evaluates the intermediate states in the plan. And we just render the values here, no brainer, right? So you can look at multiple plans. You can have even more numeric domains. So anybody familiar with PDDL, is it 2.1 with continuous effects, right? So this is a domain that has continuous effects, and it can make coffee. Any technology that can make coffee is good technology, right? It's good demos, right? So making coffee consists of boiling water, and that has a continuous effect that the water temperature is rising as time goes by. And the second is that you pump cold water through the boiler that's been heated up to that temperature and make coffee, pass it through the coffee itself. Right, and we'll take some initial state like room temperature, and my cup capacity is a large mug, in fact, and there is nothing in it, and I have a numerically defined goal even, right? I want to reach the capacity of the cup by raising the level in the cup. So if I run that, I get a plan that's basically, because it's a large cup, the water is boiling. But when it reaches 100 degrees, we start pumping, it cools down, cools beyond 90, and we cannot be making coffee with water that's less than 90 degrees Celsius, right? So you can see how richly numerically, you can get the planner to tell you that, yes, to fill up the cup of that size, it's going to actually take 145 seconds. Yeah, that's a lot of coffee.
That's not so bad.
Right? But what you do from here, for example, you can look at the actual plan. So I can save the plan, into a file, and for future things like that, I'll disable the sound coming out of here. And this is the plan in the regular PDDL-ish way. Note that we have syntax highlighting and jump to declarations, right? You can go to the domain file as well from here. But you also have the other things, because the validator is installed. You can get it installed and validated by just right-clicking on the file and seeing the result. In fact, you don't have to do that, right? If you just say mistyped anything in here, you said, well, there's some wrong syntax over here, Val will catch you, right? It will tell you, no, that's not an action that actually is known here. And if you say, well, actually, let's do something else before I start modifying this further. I can right-click on the plan file and say, give me that view of it again, right? I want to see it visually, right? So perfect. So when I can see it, and now I can start fiddling with it. So what would happen if I started boiling far earlier? If I started boiling after 50 seconds rather than 70 seconds, right? What happens here is that, okay, I get caught. Oh, I get caught for a wrong reason. I get caught because the problem file was no longer open. So it couldn't associate the domain and problem files properly together. Come on, you can do it. Can you do it? Yes. I'm going to tell you what file I mean. No. Yes. So that was my problem file. You can do it, right? So let's try it. All right, there we go. So it pulled my pumping action far earlier, and actually to make it even more visible, I'll make it 20 units of time long, right? So now you can see that my temperature is all over the place, right? My temperature goes only to 30 and then goes down to 10, right? And it cannot make good coffee this way, right? But you can make these modifications. If you try to see what's wrong with my domain, you can write plan by hand, see it visually, so that it kind of makes sense. Otherwise, it's hard to see what's going on usually, and get Val to tell you what's wrong with it. Now it's telling you are missing a precondition. You're violating a precondition or a duration constraint, things like that. So then you know, aha, okay, that's what's wrong in my model. I'll modify the model and try again. Right? So this closed loop around to the plan and getting the help from all the Val tools is usually very helpful.
And it's worth emphasizing at this point, I mean, it's not a mixed initiative planning. You don't adjust the boil water and then it will fix the rest of the plan for you. That's not what this is meant to do. But if you've ever diagnosed PDDL that you're trying to write, and all of a sudden the planner says no plan can be found, and you say, no, that can't be right. This is a perfectly valid plan. Why don't you do this? You can change your initial state. You write the plan by hand, and then the validator will say, well, no, this isn't going to work because this is where it fails, and this is the point where it goes off the rails. And so this is a very common technique that if you've written enough PDDL, you've used yourself in very hackish ways with syslogs and dumps and so on. But now this is fully integrated for you.
Thanks. So where you can go further is you can take this temporal plan, which still has one line for start and end, and for some other modifications in the temporal sense, it's more useful to break it down to basically these snap actions or happenings, one after the other, whatever we want to call that. And no, that was saved somewhere and disappeared. But yes, that's a file called .happenings. If I open that, now you see the temporal shape of it, exactly, what's happening after, one thing after the other. And because there are actions that appear multiple times, you can see exactly which one is opening and closing, so you can pair them together, right? So now, I hate you. That's happening because it's finding another version of this in Git. This may not work. Yes. So what do I do? What do I do to?
And so as a quick poll, we asked earlier on who has used the online and the offline versions. Actually, perhaps a more pertinent question is who's ever had to teach PDDL in a classroom setting or otherwise? Right? At least 1, 2, 3, 4, 5, 6, 7, right? And so the feedback that you guys have is absolutely vital for improving the online version of this, the offline version of this, the integration of this, how things are set up and so on, right? We have our limited view of how we've taught things to other people, but those who have run a course with 100+ students trying to write PDDL simultaneously, I know you're slamming my server, so I know you're out there. It's worth getting feedback on what's working and what's not.
All right, I think I managed to get it back. Now, the most fun part, when you try to find out, numerically speaking, what's happening during the plan, is that you can right-click on that happenings file, and now because these are state transition one after the other, you can ask Val to evaluate each of them and show you the effects. Now, like in a debugger, when you are in a debugging session, usually you see in modern IEEs the values in your variables that you are modifying, right? So here you can see that the effect of pump boiling water is that the pumping predicate is now on, and the new water temperature is 105, and it rises as we go, right? Goes to 115 and then to 105. The ultimate level of debugging of your plans, basically. All right? Makes sense? Have you got Val? Except for the people on macOS, it's now all available freely.
I had Val here. I tried to configure to
To point to the new Val, I think it might need an updated version of Val, which might be the issue, yeah.
Yes.
But if you have figured out how to get Val working on Mac, then...
There are other binaries that are coming now. Yeah. There is a utility called...
Oh, the standard GitHub worked for you. Okay.
Yes, so that doesn't have all those things exposed yet, but that's coming to that Git repository soon as well, as soon as we get it cleared through lawyers. All right, so we had the temporal plans, deeper look at that, and valstep, which is basically the utility that steps through the plan and iterates val. And we are done there. Now, even more hardcore things. Are you ready? Or you have a question on this level? No? So what would happen if you wanted to put a domain like that into production, onto production server, into a real architecture, a real deployed system? And you wanted to maintain
right? A real coffee machine.
A real coffee machine, right? That people go and hit it every 10 seconds. You would maintain that domain file further over time, and you will make mistakes, right? What worked before didn't work anymore. Actually, you would never do that. You would never make a mistake, right? But the next person after you, who would never understand your wisdom, they would make some wrong assumption or violate your assumption, and bam, it would not be making coffee, or it would be making coffee from cold water, like what I was getting there, right? So instead, how do you protect from that is usually continuous integration and a lot of test coverage. So how do you get test coverage? So I showed you the file like that, where you can specify the cases one after the other, and you can even say what we had there earlier, the expected plans. Right? You can have multiple plans, and as long as the planner hits at least one of them, it will pass the assertion. This actually raises further questions. How do you test an AI system, right? By another AI system? Right? No. So here we try to be on the rudimentary level, and we say the plan has to be one of these expected plans. But then, if you have many problem files, that will be rather tedious to maintain, right? Here I have several problem files, 1, 2, 3, 4 problem files just for the coffee machine, right? But maintaining that over time, when you change the name of a predicate or when you try to remodel the things completely, then all of those problem files, you've got to basically revisit them, rewrite them, and that's just pain and pain and pain, and you will stop doing it, right? Because it will just not be sustainable. What we suggest instead is that you do something like this, and here what I have pulled out was, pull this again. I went down to a case which has some other extra logic in here. So I have the domain, I have the problem, but then I have a pre-processing step, right? And if you've done any web development, you would perhaps come across libraries like Jinja2 or Ninjax on JavaScript, or a number of other templating libraries, right? So this is just one of them. Take it as something that can take a template and populate values into the right places. And what values are being inserted in there? Well, they come from a JSON file here. Right? So I've replaced many handcrafted problem files by one with many machine-readable, machine-generatable JSON files. And if you don't like JSON, you can use anything else anyway. Where is the file? Let's open that again. The end result of it will look like regular PDDL, right? So you would not know that this came from some code generation. So let's just double click on that so it stays open and go to where the other files are. So the template, let's put it somewhere in here. Template is here and the data files is there, and you can look at it all at the same time. Hopefully this is readable. So the problem file still has the familiar syntax, except that there are some new things with these curly brackets, right? So that's exactly the templating language and its syntax. You could basically point to your data and pull out the name. So even the problem name is coming from one simple JSON property down there. But you go, of course, with something more interesting, like all of your locations. This is the driver log domain, if you came across that in IPC, in the IPC set. You can take all of the drivers, pull their names, and then join them by a space, right? And that's all your drivers. And that's basically coming out of right here. And it's printing that, right? I have one driver over here. What, just to show you that it actually works here, what can I do when I'm setting up the drivers? I'm looping through all the drivers. Where is a for loop for all drivers? Print the initial location, right? So I can actually add another thing here. I can say driver has a mood, and depending on the mood, they may actually want to drive or not. So mood is, say, bad. You can make it a string just for fun. And add a thing here, mood, driver, mood. And what happens here, you can see as I'm typing, it's basically showing me the preview of it. And not just that, I get a squiggly line here by the validator, right? It's telling me, what, mood? You never told me about that, right? So then, of course, I would have to add a predicate and so on, right? But you see how, even though this is templated and this is not PDDL, this would not parse by PDDL, right? The magic is that you can also tell it, oh, by the way, before you parse it, just always print this unit of data into it, so it becomes proper PDDL before you throw it at the unsuspecting PDDL parser, right? And yeah, you can, of course, what you do, why do you want to put data into, say, some JSON file like that, is because at development time, you can create as many of these as you want to with no additional modeling effort. Driver 2, let's say, right? And as long as I change this, it will refresh. Yeah, okay. Now we will get 2 drivers magically, right? But when you deploy this, you can use the templating approach. So the Jinja templating library is from Python. If you have your architecture based on Python, or at least that service that generates problem files, it will generate from any data, right? So you have data coming from sensors, data coming from databases, IT systems, whatever. Just get them to produce JSON, and you can produce an initial state from it and plan and replan as you wish. Right, Philip?
Yep.
That's what he's doing. Okay. Make sense? Any questions? All right. So what else do we have on the list? Well, okay. So how do you use these tools to your advantage when it's not quite doing what you're expecting? So I have the next domain here, and that's modeling airport ground operations. Anybody came here by flying, right? You've seen that there's probably planning problems there, plenty of them, right? So in this model, I care about planes and runways and gates and cleaning crews and refueling trucks, and I could be adding baggage handlers and things like that, but that's secondary, so I decided not to put it to the planning domain. And I have a unit problem file here with one runway, one aircraft, one gate, and one of everything. And if we run that as it is, we should get the plan easily. And again, you have all of these PDDL samples shared with you. Yeah, so as you expect, one aircraft is taking pretty easy path through the plan from landing to takeoff, except that, is there anything missing? Are you missing anything on there? Can it fly? No, we are not refueling it. What happened? Can you see refueling there? Problem. Where is refueling supposed to be in this plan? Where would you expect it as a human? And latest before? Latest before what? Before, can you be refueling while you're on the way to the runway? Or you're taxiing? Not yet, they don't have that technology. So just before pushback, right? That's what you needed. So, okay, so you as a modeler would say, show me pushback. Is there something wrong with pushback? And, oh, apparently, yes. So you take the condition that the stupid modeler missed, put it in there, right-click, rerun the planner, and voila, we have refueling, right? Refueling happening as early as possible, basically as early as it is at the gate. But did you say you wanted to see it more like while we are boarding or after boarding? Or basically, why can't we have refueling just before pushback, right? Wouldn't that be more accurate? Like, don't refuel the aircraft if you don't know that it will really fly, right? To defer these expensive operations till last possible moment. How do you do that with PDDL? How do you make sure something is happening something is happening just before something else, so just before pushback? What's the tip, trick, technique? Oh, I'm going to love that competition on modeling next year.
I don't want to give away all my tricks.
Okay, nobody wants to give away their tricks. All right, okay.
Snap actions, envelope it, depends on what you're sitting in.
Yes, okay, we're gonna make sure it just happens just before that. And for that, I think I have that trick already coded out. Oh yes, it must be right here. So yes, we've tightened that model somewhat by inserting a few more predicates. Can we start pushing back? Can we stop refueling? And I've inserted this action, the clip action that basically clips the end of refueling and the start of pushback to be within 10 epsilon time steps from each other, right? So if we rerun that now, we should hopefully see our refueling to happen late. This is taking time. Okay, well that's because I was running it for many plans. Okay, so many planes. So yes, and that's a horrible looking plan. This is going to be the problem for one aircraft. No, this is still the other one. Let's get back to one plane. Just we assert that we got what we wanted. Select the domain tightened version. And there we are. So now refueling is happening late. Perfect, right? But what you actually saw a minute ago, where I was solving it for the 10 planes, it actually was taking really a lot of time to come up with the plan. I don't have it anymore here, but yeah, that was taking far longer than I expected. So what's going on there? What's wrong? And can we find out where we are wasting our time? And I've prepared just a cut down version of that. It's not 10 planes, but it's 3 aircrafts and 2 gates, and otherwise it's the same. as the one aircraft, because this should show where the problem is. And I'll get, and let's solve it, actually, making sure that everything does work. Okay, works reasonably on this level. And it produces fairly good plan, so 2 aircrafts are processed, and the third one is waiting for what? The third one is waiting for the gate to be available, right? We had only 2 gates. So the ICAPS 2019 edition of this extension comes out with this surge debugger. The ultimate tool to show what planning does under the hood to a manager. I do that a lot. And let's also switch the output to go directly to the surge debugger. Right? Now, the caveat is that not every planner on the market supports this, but it's well described what the planner needs to send in order to populate that. So, bear with me, the Titan, and 3 aircrafts, that's the one we want to run. There, stand back and watch. Right? So, I didn't run what I wanted to run, I think. I wanted to run with best first search, so we actually explore more states. The error is more visible. There we go. So now the search tree is more of a tree, right? That's the initial state for possible actions from the initial state. On the top on the chart, you can see how your search is struggling usually there. The blue is the heuristic value of the state currently evaluated, and green is make span, kind of the committed make span, the plan head of the state. This is basically state after state as they were encountered by the search. And the light green is the total, the estimate of how long is the planner thinking it's going to take to achieve the goal in time, right? The make span of the plan head plus the relaxed plan. So if you actually want to see what you're looking at, and now we need to get more space here, close everything in here, close all, and get rid of that, make it bigger. Right, so now the fun is beginning. See how easy it is to drill to the detail of it, right? So now you can see the initial state. So heuristic value 66. Why is it 66? Because there are 33 durative actions in the relaxed plan. So for the first time in my life, I could see relaxed plan visualized as well. Right? Sorry if I get overexcited. But we also said that there were 4 children of that state. Why these 4? Well, at this black arrow here is basically listing all the what's called the helpful actions coming out of the temporal relaxed planning graph. The first 4 suggested actions that can be taken right now from this state, right? And you could click on them, and it basically jumps to the state where those are applied, right? Not all of them get applied, right? Because this state wasn't explored any further, but you basically get the message. Maybe I want to make it a little bit simple. Okay, so I have some keyboard shortcuts here for the fun of it, right? We can basically zoom this back. And to a manager, right? What does a planner do under the hood? So we go to some state, and with Shift keyboard, I just go again through all the states and see where the black arrow is moving. It's moving down, right? And many of the actions are still kind of not closed. They are still open, like the refueling pushback clips on the top. But slowly but surely, the plan is taking shape, right? And now we are done. Now we can see the plan, right? But what's wrong here? Why is this exploring so many actions? And why is it that it's suggesting that from the initial state we can apply 3 of these clips, so they're grounded to planes and gates, right? So there's more than one of them. Is it actually good that those clips are applicable right at the first state? No, they cannot be clipping something that hasn't started yet, right? So, okay, now because I could visualize the bloody thing, I can start looking at, well, what's wrong with it. And sure enough, somebody left an error here as well. We are missing a precondition here, right? That start condition, we must be refueling already when we are clipping the pushback to it. So, okay, so we can try this again with this fix, run, and watch that now the search tree is far leaner. There are much fewer states explored. It's still running, it's still doing something. All right, yes, it was struggling to show, but see the blue line is much smoother, right? We are not exploring some plateaus because we have too many children to evaluate, to consider. It's basically navigating fairly nicely to the goal, steadily but surely. And there are no stupid actions being suggested too early and then kind of backtracked from. We do just the necessary things, right? And for the sake of how productive this gets when you are working with someone, we actually with my colleagues over phone and Skype, we look at huge search trees, and just to be able to talk about them, right? We have to mark some of these states. How do you talk about state? The state, then everybody has to remember state 28. Or what if we just say the state 28 is a star? So we can make this star when we talk about it, and this one could be a square, right? And they just keep that shape no matter what you do, right? You can look at other states around it and still carry the conversation about why is it's not doing this from this star state, right? Can we do other things? Can we click on it and say, can we click on this state and ask, why is it that this state wasn't evaluated any further, right? It has a heuristic value 52 as all of the siblings. Why is it that we didn't dive down this one? It's probably because of makespan, but we should be able to right click on it or click on it and say, plan from right here, right? Explain to me whether we would get a plan or not, right? So you see explainability weaved into it visually and interactively as much as you want to. But that's not done yet. If there is anybody got any spare time on your hands and some TypeScript or JavaScript skills, we could use them. It's all open source, right? So you will have it. Go for it. So we've done that, and we've done the search tree visualization and diagnosing search through these means, and that's basically the repertoire for today.
So can you open a read-only session back from one of these, just to show how it goes back?
Yeah.
We take questions once.
Could I ask you before we close this, can you one more time explain the light green versus the brown?
Yes.
Dark green.
Yes.
It's the sum of blue and dark, right?
Yeah, so dark green is, come on, make it bigger. Dark green is in the beginning 0. The initial state would have 0 or epsilon in temporal plans. It's the length of the plan head, all the actions up to this state. So in the beginning we got nothing. And at the end, eventually it resolves to the full length of the plan, right? And you can actually see where the planner is. There are some very interesting domain where you can see it, trying something and then really penalizing that state because now it has a longer make span and it's really trying to get plans that are shorter. So it goes back and can we do something else? And eventually said, no, there was no other way. We've got to commit to that expensive action and then goes further. So by visualizing this makes a lot of sense. And the light green is then if you take the relax plan that was next to it, F11, and make it a bit smaller again. If I take that whole relax plan, so this is the plan head up to that state, and the relax plan, if I would take the maximum time the relax plan could take, that's basically the size of the light green portion. So again, there you can see how the temporal planners and the relaxation, or the deletion relaxation, is basically optimistic. Right? It can do so many things in parallel. While eventually, that's really not true. Okay?
Thank you.
Are read only online? Yep. So I mean, we started it by going with the online experience and then showing how open offline takes you to the offline experience. If you have stuff installed and set up, that's where you can go. From offline, though, rather than, or you're loading and...
Just load one.
Yeah. Yep.
Okay. Of course it doesn't.
Of course it doesn't exist. Yeah.
All right. Typo, but there we are. Now we are offline. It will sync down all the files.
Yep. And so, I mean, the offline does have integrations, right? The planning.domains, this is the API that you saw before. You can load up any of the files that you would want inside of here. Say IPC 2008, elevators, PO1. Will that automatically go?
So you get the domain, the problem, and the best plan, is it? Or what's the plan showing
The
there?
domain, the problem, and the best plan that we know so far. Yeah. So the solver API, you can upload new plans if you have found new plans and so on. No changes in this read-only session, right? So if we wanted, we could, and we went over this quite quickly before, duplicate the session as a writable, generate classroom sessions, which is what we did for the intermediate here. And if you're running a classroom approach like this, you start with a template, and then open back online in the browser. And this is all using the common session IDs. It's what we passed around on the pieces of paper. It's what's being locked in for both of this. I wanted to show just one final thing that
Caveat was that this was Internet Explorer. That's Chrome. Right.
One final thing. Do we still have any of these opened up? Where was the demo session IDE? So when you go back to the online experience, again, it unlocks the things that are online that might not be offline. While we still have a few moments, and assuming the server has gone back up, I wanted to show very quickly, as promised earlier, both the dovetail and the state space, which are good exemplary things of plan, dovetail, state space, put together as independent projects that allow you, through the online interaction, to see new forms of the planning files, the search space, plans that are produced. This is the dovetail that shows the effects and the preconditions and how they link together as the plan is solved. None of this is my stuff. This is Mao's stuff, who's produced this as plugins for the online editor. And so this really shows how prototyping different ideas and visual demonstrations on planning problems can be used and integrated with this. Now, the thing that I want to show is that yes, this is a nice setup, and we advocate anybody that wants to produce something here as a plugin. We will certainly highlight it for the whole community to use. But the final thing is not all that impressive in its own right. But the solver itself is a plugin. And the new version of the solver, which is meant to be merged fairly soon, has something that looks like this. Right? And what this is meant to exhibit is the power of what is about to be released, not necessarily what you see now. So this is what a plugin looks like roughly. Inside of what you're storing when you save, instead of just the specific things for the plugin, for those that have developed plugins for this, you can inject stuff that might go into Visual Studio Code. Right? So now what's happening there is that you have an opportunity to define whatever it is that you might need on the offline experience for this, so that when you load a session, what's going to happen is it crawls through all of the plugins, and if it recognizes that somebody has stored a VS Code injection that you want to execute that code, it always gives the offline user the option to say, I'm about to evaluate something from a foreign source. Are you sure you want to do that? Yes or no. But if you say yes, this will simply show you how you can override what solver service is being used. So the online solver service, that is the plugin for the online editor, if you were to open that session offline, is going to inject and take that solver URL for the offline use as well. And this is just a very, very simple example of what you might want to do. So for dovetail and state space visualizations, if you want to have that in an offline visualization as well, it doesn't have to go into necessarily full extensions of the PDDL VS Code thing. You can actually have the plugin framework for the online operate in the offline setting as well. So again, it's not an extremely impressive demo at this point, but I hope you understand the power of what this could give you, right? Online plugins that are implemented now have the ability to affect the offline experience as well. It can be the same, it can be different, it's completely up to you. And so I think this sort of closes the loop from online to offline to online to offline again. And unless there's
But completely plainly, the vision is that the plugin can be written once and it could exist in both.
Exactly.
One investment, two enjoyments.
Absolutely, absolutely. Yeah, yeah. And so if you have custom stuff for visualizing things in a particular way, VS Code is just JavaScript and TypeScript under the hood, right? So I mean, it's same framework for stuff. Yeah. Yeah. Are there any remaining questions? Again, the asks would be for plugin developers. Take a look at this and see what you can do on both sides of things. The asks of educators, like what's missing, what are the biggest feature requests that you would have with this. The asks for general practitioners, what would make it easier to sell this upwards in management.
What about conditional effects? Are they handled?
Handled by what? Right?
By the editor and then by some plugin solver?
So I mean, there's certainly syntax highlighted. Depending on the plugins, will they handle conditional effects or not? The solver URL, it's just taking domain and problem and throwing it and hoping to get an answer back. If you have a different solver that handles conditional effects, then you just change the solver URL and yeah, it'll give it to you back like that. You might have, for certain plugins, the lack of that kind of support, but that's plugin specific. Does Torchlight handle conditional effects? I'm not sure. Maybe it does, maybe it doesn't. But that's up to the individual plugins to sort of set. The offline editor, a lot of the features are temporal only, and there's a lot of stuff you can get from temporal.
I think the parser from Val supports conditional effects, right? So it would accept it.
Yeah.
Yes.
Yeah.
The syntax will highlight it. I don't think you will get auto-completion, like suggesting that here is where you could write a conditional effect and this is the snippet for it. I don't think that's that helpful, but it will not trip over it.
Yeah. Soothe and BFSF handles conditional effects, right? Yeah. So I mean, the solver out of the box would handle it fine.
What's the follow-up?
A non-deterministic domain.
Non-deterministic domain.
So the issue with non-deterministic domains is, I have deployed it and we've sent to PDDL. It's just a very simple interface back and forth. The issue is displaying what it is that you get out, right? That is currently not yet a plugin, but there are plans to make that a plugin for a custom thing that's been written for at least my planner. Yeah. The online solver is also an open source project, so a lot of people just clone it, deploy their own solver that is a completely different expressive language, and then uses it for their own purposes. But if you want to put anything in the cloud that takes PDDL and gives you something, then it's pretty easy to hook that up.
Sorry, in the offline version, can you plug in different solvers?
Yep.
Yeah.
So to the point where on the online version, you could change the solver there, and when you open the session offline, it would actually reflect the solver that you've done. And that can be done with the VS Code injection that goes there. I think it's the overview pane that allows you to choose the solver that's going to be done. It does expect the response to be in a particular format in order to know what the plan looks like or what's coming back from the server, but yeah.
So technically, when you sync down the session,
Yep.
It basically writes it within that workspace, but yes, for this session, this is the solver, right? And otherwise, yes, as mentioned again, on the overview page, you will get these kinds of important pieces of configuration, like what solver are you going to use? You can configure it by typing a different URL or local executable, right?
Yep.
Anything in between.
Yeah.
It takes also local executables, so
Yes.
you can do everything offline.
Yes.
Yeah, no, that's absolutely key, because some people don't want to send PDDL to servers that I run, and I totally get that. Like,
I was, for example.
exactly. But beyond that, the online solver, it's extremely quick and fast and dirty. Not dirty, but quick and fast and dirty. You know what I mean, right? It gives you 500 megabytes, 10 seconds tops, and if you keep slamming the server and somebody else wants a chance, you're cooled off by 10 seconds. And so there are heavy resource constraints on using that online server. It's just meant to prototype stuff, and while you're developing your PDDL, test those things. That's why most people that actually are doing heavy lifting PDDL modeling have their own offline server running their planner in order to do that.
Yep. And then if you want to extend or modify a planner that doesn't quite conform to the expected output, Here on that page are all the details of what the executable needs to output so that the errors can be properly interpreted, right? The plan can be properly interpreted out of it. And same if it is a web server, as long as actually you implement the same
API.
solver API that's published on planning.domains, it will just plug in, no questions asked, right?
Yeah.
And then ultimately, if you want to populate the search tree visual debugger, I've got all the details for what's expected from that as well. I would love to see another planner to actually embrace that and take it to the open, because all I could show you was the proprietary planner that we are developing in our company, right? So actually I never mentioned that. But in fact, I forgot to mention to you that you can try it yourself. You can, if you open that search debugger and try mock search progress to test debugger. Yes, this is just mocked out search progression of states, right? But you can click on the states and see what the relax plan and the helpful actions are doing, and so it's fairly accurate mock data all the way down to the plan that actually state that satisfies the goal condition, right? Yep.
Any final words, Derek? No? No? Yeah.
What version of PDDL you are currently supporting with the highlighting?
Oh, with the highlighting.
Yeah.
So the most important thing is that the parser underneath
For the syntax errors.
is where you're going to get the syntax errors from. And Derek can probably answer the question as he conveniently walks into the room. What version of PDDL does Val support in the parser there?
So we'll support 2.1, 2.2, 3, but it
Three-ish.
doesn't do the multi-value domain variable.
Yeah. And for the online, like the syntax highlighting, it's just keyword stuff, right? So if you see an and, I want you to highlight it because it's special. If you see an or, it's special. If you see foo, it's not special, so don't highlight it type deal. Yeah.
Yep, it will not trip over syntax from PDDL 3, but Val may not, may be flagging some things as.
Val does that, but it doesn't do
Yep.
the extra bits of
Object fluence. Yep.
So if you see a limitation and you think it's important, then reach out. And again, Val and all of these tools are open source, so you're welcome to submit a pull request. Or just tell us what's important to you.
Yeah, and I mean for educators, it doesn't need to be pull requests, it's open issues, and we'll find people to handle pull requests. It's important to get a good sense of those around the ground teaching these to classrooms. Yeah. No?
All right.
If there's no further questions.
We would love to see what you thought, things that you didn't want to ask, but they should be said somewhere, or what did you like, what did you did not like. It's a short form to get us feedback. All right. Thank you.